Good morning. My name is Dr. Kate Rocklein. I am an associate professor. My area of research is blast-related brain injuries and other post-deployment health outcomes, mostly in military special operations. There's a lot of stereotypes and maybe even a little bit of romance or wistfulness when we think about special operators, because I'm talking about Navy SEALs and Green Berets and people that we have built up in our own mythology. And the reality is that they sustain really significant yet subtle insults to their physiologies just based on the nature of their warfare, how often they deploy, and the kind of operations that they engage in. So today we're going to speak specifically and have a discussion around the effects of blast overpressure. And this topic is really, really important because even firing heavy weapons can result in overpressures going through cerebral tissue and causing repetitive, small, microscopic damage that over time accumulates into conditions that we often see in people who are not necessarily healthy. They are not considered commandos in movies. These are people in their 70s and 80s and older stages of life who have developed frontotemporal dementia and other neurodegenerative disorders like Alzheimer's. So why is it that it's a mostly male group? Prior to a couple years ago, you had to be male to go into special operations, direct action roles. And these operators, these special operators, are generally considered some of the fittest, most resilient people on the planet. So why are they showing signs of frontotemporal dementia and confusion and psychosis and suicide after experiencing repetitive blast injuries? Well, to discuss that, we need to go a little bit deeper and review our neuroanatomy. What do we know about neuroanatomy? What do we know about what's inside our skull, other than the lobes and the sulci and all of these different, the corpus callosum and all these really significant anatomical areas of the brain that we know they do certain things, but what happens when really delicate, sensitive cells within the brains are destroyed from blast overpressure exposure? Well, if you think about a military service member in combat and they have their helmet, right? And their helmet is strapped down. Inside the helmet, there might be a little bit of padding. There's, obviously straps that hold it to the face. But what's interesting is that back in World War II, soldiers did not wear their helmet straps, and helmets were basically metal back then. And they had a lower incidence of what we consider traumatic brain injuries from blast overpressure exposure, because if they were exposed to a blast, it didn't get trapped underneath their helmet. What we found now is that possibly with advances in helmet science and head protection science, that we might be trapping the pressure in there and it's ricocheting around the brain. So let's say a service member is deployed in combat and there is a roadside bomb. Okay, that's one type of blast. That's a really big blast. Other types are from breaching, when they put explosives like C4 onto doors when they have to gain entrance into a building and conduct operations. And so when those blasts occur, there's a variety of mechanisms by which blasts occur and how they affect the body. But with reference to the brain, the pressure from these blasts goes up through the face, the pressure goes into the orbital sockets, and it hits the frontal lobe, okay? Now remember that, frontal lobe, frontotemporal dementia. So when the overpressure is centered in this area of the brain, what happens is damage to an area called the rostral anterior cingulate cortex. It's the RACC. And I remember that because my kids would watch Finding Nemo repetitively, over and over and over. And what was it? The East Australian Current, the EAC, that the turtles had to swim down. So let's think about the rostral ACC or the RACC as this pathway, okay? And within that pathway, within that little neurological housing, for example, we know that within that are specific types of neurons they're long and they're kind of willowy, they're stringy. Some cells look like a real punchy kind of star. They've got a real defined star shape. Muscle cells look different from, parietal cells, and, cells have all different kinds of shapes and sizes. But in this particular cell, it has the cell body, and then it has these really long, almost a willow tree like extensions going down the axon of the cell. Now, when there is blast overpressure, it hits those really delicate tendrils coming out of these cells, and those cells are called von Economo cells. They're also called spindle neurons. They're called von Economo neurons or spindle neurons. Now, I refer to them as VENs, and when VENs are damaged, you see subtle changes in behavior that mimic PTSD. You can see paranoia and anxiety and depression and reliving the experiences, and an inability in that service member to really get their emotions back to baseline, to regroup, to have homeostatic reset. That is a crucial part of the physiology of these cells, of what they do for the human body. And when they are damaged, you can see service members starting to show signs of things like frontotemporal dementia. And it's very confusing because this does not look, when they come in as a patient, these service members are the last people that any clinician would ever expect would show symptoms of frontotemporal dementia. So let's review our understanding of this. We have a group, a vulnerable population, who is mischaracterized as superhuman and impervious to trauma, and they are highly resilient, right? So they get categorized in this kind of, heroic type stereotype. They sustain, often with rapid deployments and repetitive deployments, they sustain what we call repetitive blast injuries, or RBEs. Okay, does anybody have any questions about that? Okay, now, for example, in contact sports, you have a phenomenon called CTE, which is chronic traumatic encephalopathy. That is a force to the head. It's a physical force. It's not a pressure. It's not a blast wave. It's not an overpressure. It's a physical force. And let's remember that that's different. That kind of trauma, that kind of insult to the body is different than a blast overpressure. Okay? Now, let's get a little bit more involved in this. I would like you to separate into groups, about, 3 or 4, so maybe 5 or 6 groups. And I want you to design a helmet that you think would provide the best protection against blast overpressure exposure for these service members. I'm really interested to see what you create. I hope that you get really excited about it. And we're going to look at what each other has done and provide some feedback. I'm really excited about this project. I think they're going to be great.